So, concerning isotopes, you'll need to know the definition of isotopes and give the two types of isotope that exist, medical industrial uses, and talk about the properties of isotopes. So let's see isotopes. These are two examples of isotopes, chlorine 35 and chlorine 37. If you find the number of protons here, so 17 from the proton number, electrons would be 17, it is an atom. Number of nucleons, so 35, so number of newtons would be 35 minus 17, that's going to give you 18. For chlorine 37, 17 protons, 17 electrons, nucleon mass 37, number of neutrons 37 minus 17, that gives you 20. Another example is hydrogen 1, hydrogen 2 and hydrogen 3, hydrogen, deuterium and tritium. So if you look at the number of protons here, so hydrogen has 1 proton, deuterium has 2 protons, tritium has 3 protons, and they all have, no, it's wrong. So hydrogen, HH1, number of protons is 1, number of neutrons is 1 minus 1, that's 0. Deuterium, that's H21, so 1 here is the number of protons, number of neutrons is 2 minus 1, that's 1. And for tritium, H31, so here number of protons 1, number of neutrons is 3 minus 1, that's 2. Here we go, that's better. So if you look at isotopes now, all these, they are isotopes. These two are isotopes of each other, and all these hydrogens are isotopes. So what properties do they have? So they have the same number of protons. So you see, same number of protons, but different number of neutrons. Again here, same number of protons, but different number of neutrons. So we can define isotopes. So isotopes are atoms of the same element that have the same proton number, but different nucleon number. That's the definition of isotopes. Atoms of the same element, so these two are the same element. These three, they are the same element. Atoms of the same element having same number of protons, but different number of neutrons. Or you could say different nucleon number as well. That's fine. So in your copybook, write the definition of isotopes. You can include the examples as well. Now, chemical properties of elements, that is reactions, depend on the number of electrons in the outermost shell of the atom of that element. If you look at the number of electrons over here, so 17, 17. If you look at here, 1, 1, 1, which means that isotopes have the same number of electrons. Chlorine, chlorine, they have the same number of electrons. Hydrogen, hydrogen, hydrogen have the same number of electrons in the outermost shell, which means that the chemical properties will be the same, because chemical properties depend on the number of electrons in the outermost shell. If they have the same number of electrons in the outermost shell, they will have the same chemical properties. They have the same chemical properties, they undergo the same reactions because they have the same number of electrons. So that's the answer. Same chemical properties because they have the same number of electrons in the outermost shell. Now, physical properties such as melting point, boiling point, density, depends on the atomic mass. So atomic mass, let's look at the atomic mass of the isotopes. So atomic masses, you see, they are different. This one is heavier, which means it's going to be denser, which means that its boiling point might be higher. So because it has different atomic masses, it has different physical properties. Okay? So that's the answer. They have different physical properties as they have different atomic masses. So you're going to complete this table and you're going to find which one from these atoms are isotopes. So there are two types of isotopes. There's radioactive isotopes. These are unstable isotopes, which means that their nucleus is unstable because of usually a very high number of neutrons make the nucleus unstable. So it's going to disintegrate, so the nucleus will disintegrate into atoms of more stable elements. So you have a big nucleus that is going to disintegrate into smaller ones, so you end up with other elements that are more stable. Okay, and at the same time as it's disintegrating, it gives out high energy radiation. So these are radioactive isotopes. And non-radioactive isotopes, they are stable isotopes, which means that it will have one stable nucleus and will not decay to form any other products. It's not going to decompose into something else. Uses of isotopes in the medical field, you need to know uses of cobalt-60 in treatment of cancer and radiotherapy to kill germs and bacteria, iodine-131 to treat thyroid cancer, plutonium in heart pacemakers, and sodium-24 as radioactive tracer. In the industrial field, uranium-235 is used as a nuclear fuel, and carbon-14 is used as in archaeological dating. Okay. Now let's see this example. Okay, so you have a box that contains four marbles. So these three are 35 and one is 37. Find the average mass of the marbles. So average mass would be 35 plus 35 plus 35 plus 37 divided by 4. So that should give you 35.5. That's the mass, the average mass of the marbles. Similarly, chlorine exists as 75% of chlorine 35 and 25% of chlorine 37. You need to find the average mass of chlorine gas. So here we were dividing by 4 because there's a total of 4. So here we're talking about percentage, so it's in terms of hundreds. So 75% is chlorine 35 plus 25% is chlorine 37 divided by 100. That gives you 35.5. Explain why relative atomic mass of chlorine is not a whole number. If you look at the atomic masses of the elements in the periodic table, so all these atomic masses, they are whole number. All are whole numbers except for chlorine, which has an atomic mass of 35.5. So 35.5, why is it not a whole number? Because that 35.5 comes from an average value. So why is it not a whole number? Because the average mass is an average of the amount of the isotopes of chlorine. So the average mass is an average of the isotopes of chlorine. Okay, so there was a mistake here. The atomic mass of chlorine is an average mass of the isotopes of chlorine. Okay, that's why it's 35.5. Now you're going to complete these questions and then we'll move to the next part of the unit. That should be in the next lesson.